we're reviewing for your position, velocity, and acceleration part of your test coming up. In this first problem, it gives you a function, which is a position function, and they're asked to figure out what the velocity and acceleration functions are. Remember, the velocity function, or in terms of t, is just the derivative of the position function. And in this one, I'm going to do a chain rule, which, surprise, surprise. So, derivative of the outside with respect to the inside, my exponent's now 1, times derivative of the inside, which is 2t. I would try to simplify that if possible. It might make your life easier down the road. But what I can see here, I can either use this term right here, or I can try to simplify it more, which would be 4t times 2t, or t squared minus 2. And I could even try expanding that, foiling that out, and get 4t cubed minus 8t. That would be a really easy way. And the reason I would do this here is because I also need to find acceleration, which is just the derivative of velocity. So it's a lot easier to take this guy's derivative rather than this product rule derivative. So when I do that, this just becomes 12t squared minus 8. So that just is a lot easier to take that derivative, and the only reason why I will expand it. Okay, at what time is the position of the football equal to 0? So that means I'm setting my position function equal to 0. So my position function being this t squared minus 2, the whole thing squared, minus 4, and I'm setting that equal to 0. Well, let's try to simplify this. That means 0 is equal to, when I expand this would be 2 to the 4th minus 4t squared plus 4 minus 4. Well, guess what? This plus 4 minus 4 will just cancel each other out, and I'm left with just t to the 4th minus 4t squared. Well, I can factor that. I can factor out a t squared, and that'll leave me with a t squared minus 4. Well, I can factor that even more. T squared, and this will become a t minus 2 and a t plus 2. So the times when my time equals 0 here would be when each one of these equals 0. So t will equal 0, 2, and negative 2. But remember, my negative 2 here is not in my domain because we set up here time can only be bigger than or equal to 0. So this guy right here, we can just kind of ignore and get rid of. So this guy is not a legal answer. Only 2 good answers for that. And something else I would definitely recommend doing as you're doing these is to box all your answers. It's a good habit to get into in terms of getting prepared for what you should be doing on an AP test. So I would even box them just like that, and I would box these guys down here as well. All right, let's continue with this one. So, at what time is the football at rest? That means at rest means velocity. So I think at rest means velocity. If I can spell it. So that means 0 at rest means velocity equals 0. So 0 equals v of t. So that means that I should take my velocity function, which we just found as 4t cubed minus 8t, or you could have used your other prior one to figure out the same thing. But here's what you should be doing, trying to factor this best you can. I can pull out a 4 and a t from this and get t squared minus 2, which actually, if I go back a page here, that is kind of a factored form we already had, so that would work as well. And what I should do is I should set 0 equal to each one of these. 0 equals 4t, 0 equals t squared minus 2. So this right here means time equals 0, so that's one place. And this guy here, 2 equals t squared, that means t would equal the square root of 2 or the negative square root of 2. But again, negative times can't happen in this domain, so I'm just going to get rid of that answer. So I have 2 different times here where I can have my football at rest. And then the last part, what is the average acceleration? Remember, when I say average, I should also look one above. Always look one above what I had before. So what I mean by that is velocity is one above acceleration, because velocity is when I take the derivative of velocity, I get acceleration. So if I want average acceleration, I'm looking at the change in velocity over the change in time. Okay, my change in time should be easy to see here from 5 to 2, and then it's velocity, so I want v of 5 and v of 2. When I plug in those numbers, when I plug in v of 5, I should get 460. When I plug in v of 2, I should get 16. I divide those by 3, so my answer should be, I get 444 over 3, and that reduces to 148. And my units here, we said it was in yards and seconds, so this should be yards per second. And really all these, my times here, I should probably label all these as being seconds as well. Always don't forget to put your labels as you go along. All right, in the next one, this problem we have g of x is the position of a particle in meters. So first again, find the velocity and acceleration function. Starting with velocity, I got another chain rule here. Derivative of the outside with respect to the inside. My exponent's now going to be 2 when I lower that, times derivative of the inside, which is 2x. Again, that's a good factored form, but I can try to make it a little bit easier. I'll have 6x times x squared minus 7, the whole thing squared. I might even try to go a little bit further than that. I'll expand that squared part and get x to the 4th minus 14x squared plus 49. And I can even distribute that 6x all the way through. And when I do that, I will get 6x to the 5th minus, that'll become, where is it? I feel like mapping it out again. Where is it? 84x cubed. And the last part will be 294x. So there's your velocity function. To do the acceleration function, remember acceleration is just the derivative of velocity. So the derivative of this guy will be 30x to the 4th minus 252x squared plus 294, just when I do the power rule with that derivative. Okay, the next one asks for average velocity. Again, when I think average, I look one above. So that means average velocity, I'm going to look at the change in position over the change in time. So if I'm going from 0 to 3, that's what I have on the bottom. That means I need to do my function, my position function, which is my original function, at those times and subtract them as well. So when I plug in g of 3, I should get 10. And when I plug in g of 0, I should get negative 341. Excuse me. So what I have here on the bottom is also still 3 minus 0. Minus the negatives plus the positive, so I should get 351 over 3, which reduces to 117 meters per second as my answer. Okay, and number 18, the instantaneous velocity at x equals 0 and x equals 3. Well, if I want instantaneous velocity, that means I'm literally just plugging in those points into my velocity equation. So when I plug in 0 into this equation, well, it's pretty easy to see that that's just going to be 0 meters per second, because everything will be 0 each term. When I plug in 3, if I had a calculator, I could just plug it right into this. But I think it's the easiest one to plug into, though, would be this first one right here. So if I didn't have a calculator, I would even plug this in and say, well, when I plugged it in, I have 3 times, well, this is 3 squared is 9, minus 7 is 2, it's 2 squared, and then 2 times 3 here is 6. So I should get 3 times, this is 4 times 6. 3 times 4 times 6 is 72. So my answer here is 72 meters per second. Again, if you have a calculator, use it into any of these will work. Usually, though, the one that's factored the most here at the top, one of these two, would be the easiest one for you to try to solve on your own, especially if you don't have a calculator. All right, and in the last set, we are given a function here that represents the position of a car. Time is measured in seconds, the position is measured in miles. Again, first finding the velocity function and the acceleration function. Velocity here, this is just going to be a simple power rule, so when I bring the 5 in front, it'll become 1/4 x to the 4th. This will become minus now a 3x cubed, and this will become a 9x squared. The acceleration function is just the derivative of the velocity function, which will become x cubed minus 9x squared plus 18x. At what times is the car not accelerating? Well, I'm looking at the acceleration. I want to know when it's not accelerating. That means it's equal to 0. Okay? So I'm going to take this function here, x cubed minus 9x squared plus 18x, and I'm going to see if I can factor that. Well, I know I can definitely pull out an x, leaving me with x squared minus 9x plus 18. I can try to factor that even more. What are factors of 18 that add to 9? Well, that would be 6 and 3. And now I have 3 different things that should all multiply to equal 0. That means each one's equal to 0. So x equals 0, 6, and 3 seconds. These are my times. Are we in seconds? Yes, we are in seconds. Those are my times when the car is not accelerating. Question 21 here asks, what is the velocity of the car at those times when he's not accelerating? Well, it's instantaneous velocity here. It doesn't say average, you assume instantaneous. So I want to know velocity at each of these 3 points we just found. So at 0, at 3, and at 6. Okay, velocity of 0. Again, plug into my velocity function. When I plug in 0 here, well, that's just nice and easy. It's 0, and this is going to be in miles per second is our unit here, which might not seem very realistic, but that's what's going to happen. When I plug in 3 into this, I should get 20.25 miles per second, which, again, doesn't seem very realistic, does it? But that's just the units that we ended up choosing here. Even if the numbers don't seem right, trust what your units say. And the last one, v of 6, when I plug 6 into this, believe it or not, I also, again, get 0 miles per second. So we can understand how the car is speeding pretty quickly here. If we're at over 20 miles in 1 second, you're probably actually going faster than the speed of light at that point. Okay, our last problem here. We have same thing going on. We want to find the average velocity now of the car. So again, average velocity means the same as something right above it. Right above velocity is position. So change in position over change in time. My change in time is from 4 to 1, or 1 to 4 I should say. So I should be looking at the function at each of those points as well. H of 4, H of 1. So when I plug in 4 into my original equation, I should be getting 51.2. I plugged it just straight into a calculator. When the decimal terminates, that's pretty easy to do. And 2.3 when I plug in 1. And then I get on the bottom still 4 minus 1. So my bottom is 3, the top is 48.9. When I do that division, I should get 16.3. And again, this is in miles per second. If I did it into a fraction, it would be 163 over 10 miles per second. Again, I should be boxing all my answers here. Even back on this problem, I probably should be boxing each and every one of those answers just to make sure you distinguish what your answer is. All right, last part. Was the car going faster when x equals 2 or when x equals 6? Well, this faster deals with speed, deals with velocity. So I need to look at the velocity function at each of these points, at v of 2 and at v of 6. Well, I found v of 6 already in problem number 21. It was 0 miles per second. To find v of 2, I just plug in 2 back into this velocity function we found in the last problem. And when I do that, I should pull up 16 miles per second. So what I should be saying here is that you were going faster at the time when x equaled 2. This is your answer. Make sure that that's what you have written down. Make sure you actually answer the question that is being asked. Well, there's your position, your acceleration, and your velocity problems. Best of luck, and don't go speeding.